All right, so if you're online and you see these little attendance quizzes or something in there, I will note that they're on campus only. It's just a way I can keep track of attendance here on campus and who's showing up, just kind of for my own records, if nothing else. So we left off talking about errors. And we said there's really kind of two basic errors you're going to run into. There's syntax. In other words, you have something wrong in the way you have something typed. You have the wrong key phrase or something. And that we have logical errors. And the logical errors are the harder ones because the program actually runs. It doesn't give you that error and says, hey, my program doesn't run. It is harder to find and to deal with. So we're going to look at those, and you'll see some of these here fairly quickly. And in fact, your assignment involves some of those. So that computer has a couple of weird things about it. And we're so used to now our laptops and our phones are all battery powered, we really need to think about the memory. And there's really two different kinds of memory in our computer. There's places we can store things forever, or as long as we don't drop it or something silly. And there's what's called random access memory. And when I restart a computer, anything that's in random access memory gets deleted. It's called volatile. It's only there when the computer is on. And we're going to look at all those locations. And that's what we're actually doing, is we're writing code that's stored in that memory, and we're running that code. Well, because of the way a computer works, a computer really only knows zeros and ones, right? That's all. It's really, really dumb. But in between zeros and ones and our decimal system, it might make sense to use another set of numbers. So we have base 2, in other words, 0 and 1, so there's only two numbers in it. And you've had base 10 all your life. You've done decimal, right? Everybody's familiar with decimal. Well, the other one we use a lot in programming is called base 16 or hexadecimal. And you're like, well, wait a minute. That seems really confusing and really screwy. But we use hexadecimal because a set of zeros and ones, if we have a very large number in zeros and ones, it's pretty hefty in length and kind of awkward. Hexadecimal lets us create numbers that are really, really short. So as an example, and I know you guys out online can't see this, but imagine if I write a number and I want to write the number 256 in hexadecimal. Or more appropriately, let's call it 255. Because our computer really does start at counting at 0. So if I want to write 256, I have to write ones, and I write them in groups of 8. So I have 4 groups of 8 ones. And in binary, that means 255 if I translated it. Well, if I had to work with that, is that kind of ugly? It would be hard to deal with. So decimal, there's some conversion problems. And if we have any math majors, we'll leave that out of the equation temporarily. But there's some conversion problems between binary and decimal. It's not as easy to flip back and forth internally in the computer. But another power of 2, like hexadecimal, or in some older computer systems actually used octal or base 8, we can do them in base 16. So in this particular case, 255 in hexadecimal, because we don't have numbers all the way, we actually use letters also. So we use 0 through 9, and then the letters A through F. 255 is also represented as just FF. And that makes life a little easier. Instead of having to write out 32 ones, I can write FF. And our computer can convert from binary to hexadecimal for us really, really quickly and easily, because they're both powers of 2. So our brains, though, hexadecimal means a little something different. So FF, and we're going to work on some of those as we go through here. So you'll get to learn to convert and play with those. But I just want to show you how we use this as a nomenclature in a lot of cases, and we say, all right, there's numbers and letters, and we're putting them all together. So I'll give you a really great example of where you can see that. All of you probably have a modem or a cable modem at your house, right? If you turn that over and there's something called a MAC address on there, you'll see that that's written actually in this hexadecimal, and you'll see both numbers and letters in there, and that's kind of a giveaway that it's hexadecimal. So hexadecimal is that intermediary between our computer with the zeros and us, because we don't really do zeros and ones really well, and they're very awkward and very long. Now internally, it's still all zeros and ones, but we've just converted into that hexadecimal. The other places you'll see things are things like hex editors. You may have heard that term. If you're in my cybersecurity class, you'll hear that term at some point, where we take things like Wi-Fi signals and we use a hex editor because we can pull that data out in hexadecimal. So we're gonna see that one quite a bit. So what I want to get out of this class for a lot of the content is really, I want you to learn how to break things down into this idea of how do I break it into solvable steps. And so part of that is, before I can do anything else, I have to be able to understand the problem. So remember those horrible algebra problems you had where I have a train and it's going east at 72 miles an hour, and you have to interpret and figure out what is relevant and what isn't? This is the same way with business logic when we apply it to programming. You have to figure out what the problem is before you can start doing anything else. And so if you rush through and you don't look at that, you're going to be in a little bit of trouble. So we need to understand the problem, plan the logic, then we code the program. So we're planning ahead. We're saying, all right, we think we need to do steps A, B, and C. Then we actually write the code. So we probably at step 1 and 2, we don't even know what language we're going to use. It might be any one of 600 plus languages. We're going to code the program. And then we use some kind of a compiler or interpreter. And for most purposes are very similar. So in our case, we're going to use Python and Python's compiler to take what we write and rewrite it. It's going to interpret what we write and put it into hexadecimal and zeros and ones, something the computer can use. So now we've coded it, we've compiled it, now we're going to test our program. So we look at it, we go, all right, let's do all kinds of fake data through it, maybe put some live data, see if it gets the output we want, and then finally we say, all right, it's ready for production. But it doesn't stop there. So when you bought Windows or you bought Mac OS X, did it stop? Did you get it at one stage, or do they offer updates? Updates all the time, actually, right? You're always logging into your computer and it goes, oh, you need to do an update. Well, that's good, because what they've done is they've found problems or issues and they're in that maintenance phase. So another way to look at that is this idea here of it's a circle or a loop that we're going to go around, and we're always in that loop. Now, it would be nice if we could develop something and it would never change, but unfortunately the world changes around us. And so if we've written an app for a phone, great, new phone versions are coming out, new features are going to be requested, so this really becomes a very circular process. So, understanding the problem. Well, this is really where the hardest part of this whole class is going to be, is understanding the problem. If I walk into a business and they need something done, how do I find that out? I'm going to become a detective. I may become almost like their counselor, maybe their preacher, who knows what, trying to get out the information. Because most people don't understand what their needs are. So you're trying to figure that out. And sometimes it takes a lot of detective work. And you go, but you want to be able to do payroll. So maybe we're at a company and they're trying to do some kind of an automated payroll. How do we figure that out? So one of the things that happens is our world has changed a little bit. We now have what we call iterations. A lot of times we'll make some sample code in a fake program or a piece of the program, present it back to your customer. or back to the board or back to your boss, and then they go, oh man, that's not at all what I really wanted to do. I need to do something different. So users, that end people, those that are paying you, those that you have to deal with, they can change their mind a lot. A lot. And they look at it and go, man, I really just wish that screen were pink. Well, that's easy to change. But if the logic of it changes, or they've come up with something new and they say, oh, you know what? I forgot in our payroll system, we have to deduct from all of our employees their bills for ride sharing to work. Maybe they're a company that has buses that deliver employees to work, and you're taking that out of their wages. And they've forgotten those kinds of pieces. That becomes kind of the hard part of this. That's where you guys, because my guess is most of you aren't going to become hardcore coders. Anybody going to be a hardcore coder in here? See, there we go, at least one. But most of you will interact with programmers in that business analyst role, where you have to help figure out the problem, and you have to figure out, how am I going to tell this coder or this programmer team, and in some cases that team may be in another country, how do I tell them what I want out of this software? So that's kind of where we leave our mark there, is how do we do that? So the big word we need to mark here is an algorithm. An algorithm is how we solve a problem. Okay. And we're going to get you some tools, and we're going to figure that out. But let's think about it already. This morning, did everybody crawl out of bed? Yeah. It's a sequence of steps, right? What do you do when you crawl out of bed? First you hear the alarm, right? And you hit the snooze. You cry a little bit inside? Yes. You hit the snooze. You go back to sleep. You wake up, you hit the snooze. Some of you may do that 5 or 10 or 15 times, right? You set the alarm at 5:30 in the morning, you finally crawl out of bed at 8:15. Yeah. It can happen. So we have that sequence of steps. That's an algorithm. So if I said, write an algorithm for your morning activities to get to class, it might be, I got out of bed, I went in and I brushed my teeth, I took a shower, and they're all a set of steps. But if we do them in the wrong order, when we plan our logic, can things go badly wrong? Yeah. So, taking a shower. Is there a sequence of steps to take a shower? Yeah. What happens if you forget to take off your PJs before you get in the shower? You get soggy PJs. Or, if you're living in Dalzell, I hear that's the way you do your laundry, right? Just kidding. You have to do things in a specific step. That would be a logical error. If you got into the shower with your PJs on, I would never know it by the time you got to class, right? So you'd have corrected your issue, but there would be a logical error. You still got to class, but there was a logical error along the way. So we are looking at a logical sequence of steps. So there is a term in there called desk checking, and we're going to do a lot of that. Because right now, do you even have anything you're going to code in? No, I haven't given you a programming tool yet, and I'm not for a while. For a reason, we're going to do what's called pseudocode or fake code. We've got some rules and some things we'll talk about, but we're going to write our code in English language, and we're going to be able to take that pseudocode then and say, this is what I want to do, and put it into any language, translate it. So, this is wrong out of our book. There are at least 600 plus programming languages, and I'm going to think if you really wanted to start searching through, you could find 1,000 different programming languages and variants, because somebody like Google will take a programming language like Ruby on Rails and modify it for their own. If there is a question in the quiz, though, and I don't think there is, I think I pulled it out, because remember I had to go backwards a little bit in this class to come back to the quizzes since I had a whole other course developed. I think I pulled out any questions about that. If you see it in a quiz, just mark, yes, there's more than 400. That would be the right answer. Okay? More than 400 also is the same, it's true as more than 600. So they have different efficiencies, different things they do. If I'm doing web coding and I want to interact, I may be using something like Ruby on Rails. On the other hand, if I'm going into a bank and I'm working on an old banking system that they're still using, I may use something like COBOL or one of these older languages. So they all have their strengths, they all have their weaknesses. So another way to look at those languages is how close they are to a human level language. The closer they are to a written language, we call them high level. So Python is actually a high level language. It has very much English-like structure. On the other hand, if I had to code in hexadecimal, then that is what we call a low-level language. And there's a trade-off with that. The high-level language takes more processing power to compile and interpret and put down as a piece of software. The low-level can run quick. Now, our computers are getting faster, so it's less of an issue. But there are still a lot of software programs that would probably run quicker and better had they been done as a low-level language than a high-level language. But high-level languages are easier and easier to write. They look like words and structures we're going to do. You're going to find that Python's not that much different than our pseudocode that we're going to create. So if we're going to write this, and we're going to put this logic into this pseudocode that we're going to build, well, we need it to be syntax error-free. So we're going to use a syntax, even though we're not writing complete computer code yet, that we're all using the same syntax. Because think about it this way. If I'm sending this code out, and my pseudocode, and I'm sending it to a company in India to write it for me, but my partner across the hallway is also sending them pieces of that, and we're using completely different syntax, is that going to work very well? No. So we want to write in the same language. So just because it's syntax free, we know that we can have that idea of logical errors. So this is really just that cycle, and I'm going to go through a little quicker here. So understand what we're going to do once we change something. So here we're repeating that cycle once we come up to the end of it. We hit that maintenance cycle. Then the next step is, well, we know that there's still that business problem. What are the changes and what are the things we need to do? And so that's how we make a little bit of a change and complete that cycle. So let's talk about our friend pseudocode. So pseudocode has a couple of really interesting conventions. And I am going to require you to have them in your particular code. So it has got to have a start and a stop. Start and a stop tells me where your code begins and where yours ends. Well, that's not that tough, is it? Notice what else we do. We use indent blocks. And we use indent blocks in Python and most of our high-level languages. So that indent block says everything at this level, so everything in this input, compute, and output, are all at the same level of that program code. It's going to run as what we call a block of code. So the best tool we have for this, to start writing this, is not Microsoft Word. Word is horrible for this. So I am going to show you, and some of you have seen something similar to this. On every PC and every Mac, there is a program called Notepad. On the PC, it's called Notepad, and I'm having a brain failure. It's very similar in... Look that up, Bailey. You can find it, I'm sure. There is a version of something similar to Notepad. It is just a text editor. It may just be called text editor. It does nothing to the code. If I do use Microsoft Word in this particular class, Microsoft Word adds a lot of overhead. Notepad, there's nothing in there. It doesn't add all kinds of overhead. It doesn't try to reformat my text. It allows me to be very simple and very plain, and that's what we want. Because Word's going to try to rearrange our blocks and add numbering and do things. I don't want that. I want the most simple version of a text editor I can get. And so what I generally do is I'm going to start out as I'll do this. I'll do a start, I'll do an end, and then I'll put my code in, and I use that indent key, and there's set points of that. So we may have multiple levels, and in fact, when you get into writing Python, you are going to have multiple levels. But we can use a very simple text editor. We don't need Microsoft Word. In fact, we don't want Microsoft Word because it gives us a lot of overhead. So I've written my first program. I've got a start and an end. Does it do anything? Not a thing. But what it does do is it's a complete program. Is that weird? It's got a start and a stop, but it doesn't do anything. So now we need to look at some other conventions. So let me move this out of the way for a second. So the other thing we have is something called a flowchart. And some of you are graphical in the way you can understand things. Some of you, text works better. What we're going to show you is something called a flowchart. You guys have seen them in other business classes. It's going to make a lot of sense when we do it. So flowcharts have some symbols in them. So we're going to try to make it as simple as possible. You are going to have to create some of these. And this is the way we can understand a problem graphically. And it makes a lot of sense. So the input symbol, so in our pseudocode we had an input, right? So here we have an input and we just put it inside of a parallelogram. And if I see a parallelogram like that, I know, great, we have an input of some sort. That's pretty easy. So I have a processing symbol, which is just a text box essentially, right? It's a square or a rectangle. And it says, I'm processing this. So in this case, I'm computing something called calculated answer as original number times 2. Okay. And then I have an output. And the output, and this one's always confused me why they don't have a separate output and input, but whatever the reason, that output looks exactly like the input. So we have 3 symbols. But really, do we only have 2? All right. We can do this. We have the ability to do this. So there's a couple of other symbols we're going to use. And so remember I did that start and the stop? In the flowchart, we call them terminal connectors for whatever reason. They're really nothing more than a little ovally shaped. So this is that same pseudocode, but now we've done it graphically, and you can see how that data comes in. So what usually we do is we graphically draw out our problem. Now in this case, it's not really tough. We all understand what's going on there, right? But this gives us the ability to start doing that. So here's our start. So left side is our pseudocode. We generally do that first. Left side is our flowchart. Right side is my pseudocode. All right, so graphically we have a start. We input the original number. And we compute calculated answer. So that's another thing we got to deal as original number times 2. And we output that calculated answer and we stop. Over here we start. We input original number, we compute the calculated answer, we output that number, and we stop. All this is doing is taking in a number from you, and what is it doing to it? Multiplies it times 2, right? That's not very complicated. Simple business problem. Text edit is what it's called. All right, text edit on the Mac. So this is pretty simple, this problem. But if you can do this, you can do any problem we have in there. So usually we solve this first. Can I write that in Word? Can I do that in PowerPoint? Can I download tools that will let me do that? There are flowcharting tools. One of them you guys can get for free from our Microsoft Imagine site is Visio. It's a great site, the tool. There's one I have used, a trial version. I have never paid for it, called SmartDraw, that works pretty well. You are certainly welcome to use also. You can use PowerPoint. Quite frankly, for this class, if you really wanted to draw it out neatly on paper and scan it in and send it, you could do that. These are not going to get that complicated. But what this lets us do is understand that problem and how the computer thinks about it. Because the computer does a lot of really great things. It can't think. It only can do in zeros and ones. But the best thing that computer can do is it does things over and over and over and over and over again the same exact way. So this program, if we took this program, and right now we don't have any other way to do it, but if we wanted to just sit there and take a number over and over again and double it and output it on the screen, we could just copy and paste that in over and over again, right? You could do it. It's not efficient, but it's still better than doing things by hand. And our computer is really, really good at that. The computer can do this 10,000 times over and over again. It does it exactly the same way. So let's picture throwing free throws. If you throw a free throw once, can you completely duplicate that effort over and over again 10,000 times? By 10,000 times, you're not going to be able to throw a free throw anymore, right? And we know that we change and we're not. The computer doesn't. It does things over and over again, and that's where its power and its advantage is it can do this repetition. So let's talk a little bit about variables. So remember from algebra we had x's and y's. Well, we don't really want x's and y's because x's and y's don't identify what that variable is. We want to use things that make sense to us. So it tells us when I look at this code what that variable is. So the example above, calculated answer. Does that tell us what it is? Yeah. X's and Y's don't. Now we have some places we use some very short names like that. Here's where the pseudocode in our languages all vary. Almost every language has different limits on how long a variable name can be. So there are languages that it can only be 8 characters, or it has to have a capital letter. We're going to write in pseudocode and assume that you can translate those requirements into the language that you're going to use. So a variable just stores information for us. That's all it does. So the most common casing is called the camel casing. We usually have multiple words. So in other words, hourly wage. See how we got that camel case? Because we capitalized the second word in there. We can't have spaces. Spaces are forbidden because the computer can't tell when you hit a space, is that the end of my code line or do I have to keep going? So we have to have our variables all what we call concatenated or all together. So there's no spaces in there. So names must be one word, in other words, no spaces. They should have some meaning, so hourly wage. Weirdly, just because it's easier to type, I tend to do this, what we call the Pascal casing, where every word has an uppercase letter. The problem is, if you translate that, a lot of computer languages don't like capital letters for the beginning of a variable. So camel casing is probably the preferred, and that's what we'll do in this class, is we will use what's called camel casing. So they will start with a lowercase. Every word after that will have a capital letter. So if you have 3 or 4 words in there all put together, your variables are going to look like that. So we have a variable. It doesn't have anything in it until we assign it a value. And that variable is just a bucket out on our computer somewhere. Our computer's got all this memory, and they're little buckets. So one of the problems we have is we give it a name, and if we don't assign it a value, do we know what's out in that bucket? What something else is stored in there? No. And so we'll show you a solution for that. So the easiest way we give it a value is we say, like this one up here, calculated answer is equal. So our equal sign really is more of an assignment operator, we call it. So it puts a value and shoves it in. So calculated answer is equal to original number times 2. What we're really saying is we're going to take original number times 2 and shove it into calculated answer. We always write them that way. The value that you're assigning to something is on the left. The equal sign means we're going to put values in there. But we always have this issue, and the book calls it a magic number. So in our programming, we'll run into just a magic number. We don't know what it does. We like to put things in variables if we can, because we can assign it a name that tells us what it is. It also lets us change it in the program pretty easily. So if I'm going to write a program and I'm going to use some of these operations, well, we have our standard math operations. Plus, minus, the asterisk for the multiplication, and slash for division. Not tough. One of the problems we run into is that order of operations, though. You guys all remember the order of operations from math? Parenthesis first, multiplication. There's a whole set of rules, and we can look those up. So we also have to decide what kind of data for most programs. Is it text or is it numeric? And usually that's, depending on the language, we may have some other constraints, but is it a number or is it a text? Now, one of the fun things is when we start working in Python, Python actually doesn't care. And so that makes life a little easier. But the way we do that as a text, or make it what we call a string, is we put quote marks on it. And that's generally the way we can tell that it's a string of text. The computer doesn't care. The computer thinks everything is a math number. It can only do zeros and ones. So we have to deal with that little issue in our end. So strings. This is what we call initialization. So the first time we use a variable, we have to tell it that it's something. So here we say, we're going to declare a variable called a string. The string name is called heading. And we're going to put in that value employee report. Here we're going to create a number. So we say we're going to create a number. It's called count of employees. And it's equal to 0. So we assign a type and we assign a value. If we don't do that, if we just assign it a type, we don't know what's actually stored there. Assigning it a value makes sure that it's taken care of. We call it garbage collection. So number of employees, we could assume it's 0 because we haven't put any value in there, but do we know that? No. So it's just that idea of garbage collection, making sure that we have everything in there. So some languages are a little different. They require some other things, but we generally want to make sure that we check that. So we also have a couple of other things. We haven't got really to loops. We haven't got to figure out a whole lot yet. We're just starting to work on our coding. But we have to come up with a way to stop our program in some cases. So we have a couple of other things we can do. Math-wise, we know we can add, we can subtract. We can also make comparisons. And comparisons give us a way we can stop our program, or we can make changes and make logical decisions. So we have one more symbol we need to add into you. So we're going to add in a diamond. So we have a rectangle, a parallelogram, and a diamond. Not horrible yet. And these really make a decision. Now, the computer can only understand 0 and 1. So how many choices do you think we can ever have? 2. I can't put 3 in there because our computer doesn't understand that. So it can only really be a true, false, yes, no type of question. It can only have 2 answers. So here, we've done something a little different. So we said, here's our start, and here we declared original number, we declared calculated number, and then we said, all right, we're going to create some kind of a loop. Because that's where the computer is really powerful. It does things over and over and over again. Our thermostat over here is a computer. It checks the temperature and says, is it hot enough? Is it hot enough? Is it hot enough? And does it over and over and over again. Same type of structure here. So we input the original number, and if you happen to put, this is what we call a sentinel value, if we put in the value 0 for the original number, that program stops. It just goes, oh, yep, the original number is equal to 0. Yep, we're going to stop. On the other hand, if the original number is not 0, then it comes down here and multiplies it by 2, outputs it, loops all the way back up to the top again, and runs that program over and over again. Now, there's some problems with this, and we're going to talk about what later, but it makes some sense that we can create that loop. This is what a computer is really good at, is doing that repetition over and over and over and over again. So, we use that, we call it a sentinel value. It's a way we stop our program. So a lot of times you'll see a program that says type 999 to end, or they call it this, EOF, end of file. So we can sometimes shortcut when we write our pseudocode, and using an end of file means we've got some kind of a terminal value in there. We don't know what, we just know that it's a way that we can exit out of that programming loop. So, programming is really, at least in the level of a computer, is fairly recent. So 1940s. We started developing computers, and we started developing, what do you think led to a lot of that development of computers in the 1940s, late 1930s? What was happening in the world? World War II. And some of that was being developed for things like how to develop an atomic bomb, how to make better bombing computers for the airplanes. And so this new programming languages that started to come out, because the computers were a little more powerful now in the 1940s, 1950s, so they were easier to use. The original programming, we had to remember what every one of those little memory addresses was. We couldn't just say, hey, I'm going to create a value. You had to figure out and know exactly where it was. And there weren't a lot of buckets in there. Those computers were pretty slow. But we've moved a little bit since then. So the newest languages look like English. We have got them in two different types. And so there's what we call procedural languages. And so that's kind of the old school method. And we now have what's called object-oriented. So we create objects or black boxes. So we create a group called people or a class, and it's got things. What do we know about people? What do we know about people? What attributes do people have? What does everybody in here have that's the same? You guys all have names? Is that an attribute? Can I say you have some form of height? Yeah, that's an attribute. Do you guys all have eye color? No? Yeah, we have all these attributes of a class, and we start using those. So you'll see that as we get further in, we're starting to do what we call this object-oriented programming. And that's kind of the latest trend. So what I want us to work on is we're going to start on some pseudocode. So if you will open up a Notepad, or what was it called on the Mac again? Text edit. So very similar. Every time I do this, I'm going to do a start and an end. And we're going to write it in pseudocode, a program. It doesn't really matter as long as you have a terminal end on there. The start, you use the stop. Doesn't really matter as long as I see that there's a terminal piece in there. And so the first thing we've got to do is figure out our problem. What might be a problem we could write a real quick program for? To do what? It comes back again. What could we write a program for in here? Why? That's the homework, and no, but a good try. No, miles per gallon. No, no, I'm seeing a trend here. You're looking at the homework, and that's good. That's good. We might look at one of those, but let's think something a little more. What else could we do in here? Mileage. What do you guys do every day? Is there something that you need to calculate? How exactly? That's a great answer. Let's calculate some money. Not on a trip. No. No. Good try. So we're going to figure out what our daily budget is or what we spent on a day. For a vacation? No. Just on a normal day. And so we're going to put in some variables. So the first variable we're going to put in is we need a name for this program. So I'm going to tab in, and we're going to declare a string. And we're going to say user name. And we're going to originally set it equal to blank. So that garbage collection. So every time we declare a value or a variable, we have to give it some form of value. If we don't, I don't know what's in there. Yes. Yes. So, string, and we declare it's called username, and we said it's equal to blank. So I'm going to come down on my next line, and I need a number. So I'm going to put in a number. I'm going to declare it as a number, and I'm going to say purchase. And I'm going to set that equal to 0 also. And I probably need one more value in there to start with. So if I'm going to list a purchase, I probably need a calculated total, right? So I'm going to do it again, a number, and I'm going to call it calculated total, and I'm going to set it equal to 0. So that's just kind of my header piece. We declare all my values, just kind of a good programming construct. So what do I need to do next? So I need to input username. So does that make sense? I'm going to take in a name. So now we have a name, a value in there, right? What do I maybe want to do next? If I've input a name, input, do I need the purchase? So the reality is you would construct it where it would say, hey, welcome to our system. Put in your value of your first expenditure, right? Okay. Oh. Now, how am I going to figure out what calculated value is? Okay, let's think about it a little more in depth. So you say we need a compute, which compute. What is it as? That's the person. Whoever comes in here says, here's my username. And it's just asking, hey, what is your name? So we ask their name and we ask your purchase price, whatever you've spent. So what I would suggest, let me just go backwards and show a structure that would actually work for something like this. So this is going to look a little weird. So calculated and remember that equals really is an assignment operator. We're shoving everything into that on the left, right? So calculated total. I am just trying to make it a little more obvious. So it does not probably matter. A space makes life easier. So calculated total is equal to, well, we know we want to put in that purchase, right? But if we're keeping a running total, do we also need it to have a value of what calculated total was previously? Oh, so I'm going to rewrite this just a little bit. Plus purchase. So now, if this were in a loop and going through multiple times, it would take whatever you put in as a purchase price, it would add it to that calculated value, and re-put it back into a new value for calculated total. So I'm going to space down just a second. We really don't know how to do loops yet, so here's what I'm going to do. I'm going to use copy and paste. So in this program, you're only going to be able to input 4 items in a day. So at the end of each one of these, so I input a purchase. So let's say I spent $1. Calculated total, what's its value to begin with at this statement? 0. So over here it's 0 plus $1 equals $1, I hope, and it's shoved into calculated total. In this next one, then this is $1 plus whatever my next purchase is. And so each time it adds it in there and puts it back so we can keep a running total. So what I might want to do then is have an output. And again, cut and paste. This is one of the few classes I'm going to tell you copy and paste is really your friend. And so I've just added in, go backwards one. Let me change where I break that out. Output calculated total, output calculated total. So now we've got 4 purchases in there. And at the end of the day, it can say all kinds of things. So maybe we need one more variable. So instead of putting a magic number and just putting in a number for what my budget was for the day, maybe I'm going to create one called number budget. And I'm going to set that to $10. So I can do that at the top of my program. And so down here, I want to see, did I spend more than my budget? So we don't have a lot of comparison, a lot of skills yet in here. But what if I just said output yes if calculated total is less than budget. Now, we'll get to how we do those later on, but does that make sense logically that we could do that? So we're just asking that question. There's other ways we could do it. Could we just subtract them and put out a value of what is your remaining budget for the day? Sure, you could do that. You could say, we could create another variable up here. and we call it budget remainder. We're going to set it equal to 0. We always put something in here as a value so we don't have, and so instead of doing this, we could say output budget remainder. So that would tell us how much is left, right? Is there anything wrong with that? I'm going to output budget remainder. That seems to make sense, right? What's wrong with that? I created my variable for budget remainder. What's it going to output? 0. Did we ever modify it or change it? No. So we would need ahead of that at some point. Budget remainder is equal to what? So budget minus and would that tell us how much is left out of the day? Yeah. So if I had done this differently, so rather than have a budget, if I just put in a number here, logically, is that still going to work? Yeah. The problem is, that's that idea of that magic number. What if I want to change what that budget is? Well, I can go into the code, but maybe up here, I could change it very easily. I could also do this. And change it where we're actually asking them what your budget is. Input budget. And so now we make it completely programmatic, where it pops on the screen and says, what's your budget? What's your name? And then it adds those up. Now, eventually, we were going to put those in a loop, right? That would make more sense. But right now, we just know how to do things in what's called a sequence, or in other words, from one end to the other. So that's really exactly like your homework. So let's look at your homework. Where is it? Assignments. I get to the right one. So your assignment has some pseudocode. There's a couple of things wrong with it. So let's actually look at number 1, and I'm going to copy it in here. I'm going to put that into Notepad. File new. I'm not going to save it. So there's one other thing in here we haven't really talked about. What do the slashes do? Comments. Slashes mean it's comments. The program doesn't read it, but it's for us. And so the more comments on your bigger programs, the better you are. So what is this program missing to start with that would start and stop? So let's fix that first. Okay, so we fixed that. So if I fix that, I probably should indent those, right? So it shows that all of that is contained inside of there. All right. What else is it missing? So think back to our program. When we used a variable, what did we have to do with it? So you have to declare or tell the computer ahead of time what that program is doing and with that variable. So I'm going to make a space. And so we need to declare it. So what are our variables we're using? All right, so we have 2 of them. So we're going to say num. So we're declaring a numeric variable, midterm grade. And we always set it equal to 0. just so we clean out that garbage. We don't know. Somebody else's grade might have been in there, and you don't want that 42% grade. You'd like your A, right? So I'll do that for both of them. So I'm going to declare this one as final grade equals 0. So we just did a little housekeeping, cleaned it up. If we are using it as a variable, which we are, yes. Good catch. So numeric average equals 0. Now, some languages are very picky about this, and some will allow you to declare variables inside of the code. So in our case, so we'd like to, it's kind of handy because now I know all my variables right up front. So, all right, let's take a look at that. Input midterm, input final grade. So what might be wrong with that? Oh, so there's a typo here, right? So we're trying to use final and final grade are not the same thing. So we would have to fix that. Well, I don't know. How many grades are there? How do you do an average? Divide by the number of items? Oh, so we probably need to change that to 2. Are we done? So, because right now, with the order of operations, what's going to happen? It's going to take your final grade divided by 2 and add it. So you're going to end up with a really weird score. And you can desk audit that. So let's say this one was really equal to, let's say you got a 90. And you got a, let's make it easy. Let's do, you got 100. You were that smart. So right now, it's going to say, all right, so I have a midterm grade. Or is it? What is it actually doing? Take a look at that again. Oh. Man, this programmer, we have problems. All right, so now we know that our average is going to equal 90 plus 100 divided by 2. And if we didn't change anything in there, what would that actual grade be now? What would their average Oh. What should it be, though? If you just look at a 90 and 100 and you averaged them in your head, what would it be? Yeah, so we have a problem in there, don't we? The program's going to run, but that order of operations comes into play. So it's going to say, do this first, because we always do multiplication and division. So we need parentheses, yeah. So here, and so now it's going to take 90 plus 100 and add those together to get 190. Then it's going to divide that by 2. Now does this program seem to make more sense? So now we have a piece of pseudocode that says here you're going to put in your 2 grades. And it's going to average them. I just put them in. This is called like doing a desk audit, and sometimes I will just put values in and work through the magic and the logic and see what comes out. Because that a lot of times, if I put in for a 90 and 100, and I did this quickly, and I do a desk audit and it says, whoa, I'm getting an average of 140, that should set off that alert, right? And so that's what we're looking for. So I know at least on 2 and 3 that there's a couple of things you can do right away. but it takes working through this and trying to figure out what they did. So 1, 2, and 3 are pretty easy. We just solved one. What I would like you to do, though, is use color or some other way so that I can see what your corrections are. So one easy way you can always do that is you can put comments at the end of the line. So the same structure, added parentheses and changed dividend. So somehow you can show me what you made a change in there. So 1, 2, and 3 are pretty easy. You're really looking at somebody else's code. Number 11, though, you have to figure out the logic of how to calculate, in this case, a pay rate. So you're going to figure out what somebody makes. So they're going to put in their pay rate, the number of hours worked, the percentage of gross salary that's withheld. Remember back when you got your first paycheck working somewhere and you were all excited and you said, man, I'm making $8 an hour and I work 20 hours and I'm going to get, $400. And then you got your check and it was like, oh, who is this FICA and tax people? That's that percentage of withholding that they take out. So you're going to ask them that percentage of gross salary that's withheld, and then you're going to figure out how much they are going to make after taxes, and then output that after taxes. So this is one, it's probably an advantage to create a flow chart to do this. So I can fire up something like Word and use the tools in Word, and I can create that because we only have a few symbols. So it's probably a better way to start understanding that. So shapes come in here, and you'll notice all the shapes you would ever need are up here. So flowchart actually has its own little area even. So a terminator. So hey, we're going to put a terminator in. And then I know that I have one at the beginning and the end, so I'm going to copy and paste. Now I have a start and a stop, right? So if I look at that code, what am I going to do? We've all calculated our own payroll before, because you figured out these kinds of things, but we need to try to do it graphically and in pseudocode. So it's a little bit of a challenge. So take it in steps. Work through what you've done. So if I said, oh, I'm going to input my number of hours, and I'm inputting my pay raise, and I added those together, is that the correct way to figure out what my gross pay is? So you're going to get a couple of things as inputs. So again, I can add, somewhere in there is the insert shapes. There is that parallelogram for input. And quite frankly, if you do on your flowchart, you input everything all in one time, you are certainly able to do that if you want to shortcut that a little bit. So what things are we inputting from a user? What are we getting out of the user for problem 11? Okay, so pay rate. Hours worked. Is there anything else we need? We got hours of how many hours they worked and their pay rate. Is there anything else we need to ask the user? Oh. So you could say percent so if you've ever looked at your gross pay and your net pay and figured that percentage, so for example here, I know that I take home 51% of what my gross pay is. I can put in that number. So then we can do, you're going to probably make some kind of a calculation. Then you're going to do probably an output. And that's all it's really asking. But you have to come up with the steps to do that. So if I break this down, then I can start putting it down into my pseudocode where it's a little more detailed. Here's pretty vague. But we're breaking down that process as kind of in a big picture. The pseudocode, then we break it down in smaller pieces. So, unfortunately, this is not one where you can just observe. You have to sit there and try it. Once you come up with either the flow chart, work numbers through it and see if it makes sense, if you've missed something or skipped something. Or if you've got something out of order. So put in your own salary if you want to. So we're going to have some calculations in there. And finally, at the end, you're going to have an output. And that output then, net pay. So somehow you're going to have to get from here to there. So we'll give you a pretty good start on it. How do I figure this out? You guys have done this in your head or written it out before. Now we're just making you formalize those steps and how you got to that particular point. So for this week, you have a couple of things you need to do. So make sure you have introduced yourself on the discussion board. There is not another discussion board or anything due in there. There is, I would open up the class instead of that. There is, however, this assignment to finish up. And notice this portion's 11 points out of the 20. So each one of these is 3 points, and you should get at least 3 because you all got the answer to this one. There is a quiz to take over that chapter 1 out of the book. And for next week, you need to read chapter 2 out of the textbook. And that is not the Python coding book. It is that PDF that's in week 1 up here. So you're going to read chapter 2 out of there. All right, any questions? Anybody turning in their homework as we speak?